you can think of me as a star-forming region of space, and you as the James Webb Space Telescope. Hey team, welcome to an extended cut of a video I made a little while ago for an event, but I wanted to re-edit it and include some extra footage. This is partly for fun and to have a version of the video that stands all on its own, but it's also to celebrate the fact that the JWST team have just announced the release date for their first full-color, full-resolution images. That date is July 12th, so get excited for that. These will be the first real beauty images to come from Webb. All the ones until now have been for calibration purposes, so these new ones will be even cooler than what we've seen so far, and they should rival Hubble's flagship images for beauty. Please feel free to subscribe, and I hope you enjoy this longer cut of why JWST is an infrared telescope. In this video, I want to show you how an amazing new space telescope will see the world. Over Christmas, you might have watched a rocket launch the James Webb Space Telescope into space. It's often called the successor to the Hubble Space Telescope, but it actually looks at the universe in a very different way. While the Hubble telescope looks at things like stars, nebulae, and galaxies using visible light, the same kind of light that our eyes can see, the James Webb Space Telescope, or JWST, will look at these objects using something called infrared light. On the spectrum of light, infrared light has a longer wavelength than visible light, which means that it has less energy. I want to show you the differences between these types of light and why the JWST has chosen to look at a different type of light to Hubble. I mean, Hubble was pretty successful and it produced some incredible images, so why would we change things for this new telescope? To show you the differences, I'm filming this video on two cameras. One is a normal digital camera, which is capturing the footage you're looking at right now, and the other is a camera that can see infrared light instead of visible light. This is often called a thermal camera, because infrared light is given off by hot objects. So in this footage that you're seeing now, which is from the thermal camera, the brighter spots are hotter areas in the room, and the darker areas are colder. This is how JWST will see space. So when I show you the thermal camera footage, I want you to think of it as JWST's point of view. And when I show you the normal camera, I want you to think of that as the point of view of Hubble. So let's do some experiments to see how looking in these different types of light changes the way we see the world. First of all, I'm gonna put my hand inside an envelope, and I want you to guess how many fingers I'm holding up. So between 0 and 5 are your options. When we play this with the visible camera on, it's pretty hard, isn't it? You really do just have to guess. And you probably didn't guess the right answer, which is that all 5 fingers were held up. If we do the same thing looking through the thermal camera, it becomes much easier, because with infrared light, you can see through the envelope and see my hand. This is because my hand is relatively hot and it's heating up the envelope, so you can see the infrared light, even though there's an envelope in the way. So now you can see me holding up all 5 fingers. Okay. Now let's play the same game, but instead of putting my hand inside an envelope, I'm gonna put it behind a pane of glass. I won't touch the glass, I'll just put my hand behind it and I'll hold up a different number of fingers. And again, I just want you to guess how many I'm holding up. Now, with the visible light, this is very easy. As you'd expect, you can see straight through the glass and you can see I'm holding up 3 fingers. Let's switch to the infrared camera now, and I'll change the number of fingers because you know the answer. But the surprise is that on the infrared camera, you can't see through the glass. It looks completely opaque and cold to the thermal camera. This is because the camera basically sees heat, and since my hand isn't touching the glass, it isn't heating up the glass at all, so we can't see anything through the glass. If I bring my hand forward and touch the glass, then it'll slowly heat up the glass, and my hand will slowly appear in the infrared camera. I can then even take my hand away completely, and the handprint will stay on the glass for a while, due to some residual heat that I've left behind. This is all pretty cool, but what does it have to do with our telescopes? There are no envelopes or glass panes in space, so why does this matter? Well, there's no envelopes, but there is a lot of gas and dust that can get in the way of what we want to look at. This photo was taken using the Hubble Space Telescope, using visible light, and while it looks very impressive, all of this structure here is actually space dust. This can often hide things like stars or planets, because a big cloud of gas and dust is the perfect place for these things to form. This means that we actually miss out on seeing these things when we want to use visible light. However, if we look at the same thing using infrared light, then just like when we looked at the envelope, we can see straight through the dust and see all the stars hiding behind. We can actually see this effect in real time too, using the 2 cameras we have here and a smoke machine. For the sake of today, we can think of the smoke as space dust. And for the sake of science, I'm going to fill this room up with space dust and we'll compare the two cameras. While the space dust builds up in here, I should say, please don't try this at home. I'm doing it for our experiment, but I never recommend filling any room with smoke or with space dust. Okay, now that the room is nice and full of space dust and gas, you can see that through the visible light camera, the point of view of Hubble, you can't really see me at all. I'm hidden behind the dust, so if I was an interesting space object that you wanted to look at, you just couldn't do that using the Hubble telescope. However, let's switch to the point of view of the James Webb Space Telescope, using infrared light and our thermal camera, and suddenly I appear out of the dust. My heat gives me away and it safely travels through the dust and gas of space, and you can see me very clearly. It's like the dust isn't even here. You can think of me as a star-forming region of space, and you are the James Webb Space Telescope. This is why JWST uses infrared light, so that it can see into the gassy and dusty areas of space and study things that the Hubble telescope isn't able to see. Stars and planets often form in these dusty regions, so JWST will be especially good at looking at the very early stages of the formation of these objects. Some of the oldest objects in the universe also give out infrared light, so JWST will also be able to look back further in time than Hubble can. This is why JWST uses infrared light, so that it can see through the gassy and dusty areas of space and study things that the Hubble telescope isn't able to see. Finally, let's take me out of the picture and try to look at some stars through our dusty room, to try and show you what things might look like in photos taken by JWST. I'm pretty big in this room, but from our point of view, stars look quite small on the sky. So let's see if we can see smaller objects through our space dust. I have here some small bouncy balls that I've wrapped in tinfoil and heated up, so they'll glow nicely for our thermal camera. But will we still be able to see them through the space dust? I'll get out of the way and let's compare what we can see. Balls up, smoke on. Okay. Through the visible camera, as we probably expect, these stars are totally hidden to us. If we switch to the thermal camera though, they appear and they're quite easy to spot, even through all the smoke and gas and dust. I hope you enjoyed this look at different types of light, and I hope it explained why the new James Webb Space Telescope is using infrared light to look at the universe. Feel free to subscribe if you enjoyed the video and thought me filling this room with lots of steamy, smoky stuff was actually worth it. There'll be lots more web videos on the channel, especially when those first full color images are released. You know I'm going to want to talk about them. Until next time, stay safe team. I'll see you soon. Bye! If you hear a dum 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 doof, it means I passed out because of all the smoke.